Hey everyone, this is equation of a circle, which is the first topic of our chapter 10 that we're on. Um, so hopefully at this point you're already familiar with what a circle is. We talked about that in a previous chapter. Sometimes we refer to it as or at least I refer to it as our uh, infinitygon, our polygon with infinite number of sides. Which technically um, ends up looking like a circle, but it's not really a polygon. All right, so in this first problem, which I have a good chunk of it worked out for us as well, on the image that we have on the right is a circle we're talking about. This is a circle with a radius of 10 units centered at the origin. So the center is at the origin, and radius of 10 means it's this distance here, or maybe we could say it's this distance here, or even this distance here, which is what really our first question is, what is true about every point on the circle? So it doesn't matter which point I choose, any random point. What do they all have in common, or what's true? And what's true is the units is always going to be 10 units. Doesn't matter if you're going in positive direction, negative direction. It doesn't matter. These are always going to be 10. So that's a nice part about a circle. We always know the distance from the center to any point is going to be the same. All right, so that being said, what is the value or the y value when x equals to 6? So if this x value, if I say this is 6, then we want to know what's the y value. All right, so x is 6, y, what is it? All right, so if you notice, there's already this right triangle drawn in our circle. So our y value is our height, our x value is our width, and what it looks like, this hypotenuse of our right triangle is their actual radius of our circle. All right, so if you hopefully recognize the shape, right triangles, how do you find the missing side of a right triangle? Well, if this is 6 and this is 10, what triangle do we know of that has measurements like that? So I recognize this as a Pythagorean triple, 6, 8, 10. So in that case, I could say y is equal to 8. Or you'll notice I also have y is equal to negative 8. So I don't have it drawn in here, but I can. If you notice, I could draw in a right triangle that goes down. It still has an x of 6, a radius of 10, and this has a length of 8, but it goes down in the negative direction. So this would have a negative 8, measurement of negative 8. All right, so that means that gives us 2 points. So 6, 8, and this would be 6, negative 8. All right, so those are the 2 points that I have here. So with this one x value, we actually end up with 2 y values, which by definition means this is not a function. All right, and that'll come up later. When x equals to 3, what if I change this? So this x is not 6, but what if this is 3 instead? Well, this is not a Pythagorean triple, but it is something I could still use the Pythagorean theorem with. So you should notice, I've already have this set up for us. So I have 3 squared, so this would be our x, and then I have plus y squared, there's still y, we don't know what y is, but our hypotenuse is 10, so this is going to be 10 squared. All right, so all I'm doing is really just using Pythagorean theorem. Pythagorean theorem. All right, so if I solve this, you'll notice I end up with y squared equals to 91, which means, let me go back here. So this is y equals 2 plus or minus the square root of 91. So that means that our y value down here is going to be, so 3, oops, this is going to be 3 comma negative square root of 91. All right, it's okay if it's a square root. You'll notice it's not going to be a nice whole number, which it doesn't have to be. All right, so that's a nice part there. So, all right, so let me erase that. I don't want to get us confused. All right, so there's definitely two answers there when x equals to 6, and this is kind of the process we're going to follow with really any set of points. So if we're looking on part D, it says equation for all points x, y. So what if we don't know what x is? Just like we didn't know what y is, we don't know what x is. So same equation, you'll notice, same equation, except instead of 3, we're just going to put an x. All right, so you'll notice now we have an equation that has x's and y's in it. And the only thing we really knew was this 10, which was the radius. Well, let's see if this works. Part E, does the equation work for these 3 points? So we have 10, 0, which is this point. If I plug in 10, 0 to this equation, does it work? If I plug in 0, 10, 0, 10 is up here up on top, does that work? And negative 8, negative 6, so negative 8 is going to be somewhere over here, and negative 6 is somewhere over here, so negative 8, negative 6. So again, if I draw in a triangle, this is negative 8, negative 6, this is 10, is that still true? And the answer is yes, right? All these points are true. All right, moving on. So let's see if we could try this. I've tried writing an actual equation. Here we have four problems on number 2. Write an equation of a circle with a radius of 4 units centered at 0, 0. So you'll notice we're still centered at 0, 0. The only thing that's changing is the radius. Instead of a 10, now it's a 4, which tells me really I could just write this as exactly the same. X squared plus y squared equals 2. Instead of 10 squared, it's just going to be 4 squared. Right? And that's it. That's our equation. We're not solving for x, we're not solving for y. This is not an equation we're trying to solve. We're just trying to represent what a circle would look like in the form of an equation. All right, part B, circle centered at 0, 0. Same situation except radius of r. Okay, so you'll notice we don't actually know what r is, or the radius, so we're using the letter to represent that. So same thing, x squared plus y squared equals 2r squared. All right, so this is what's known as our equation of the circle when circle is centered at 0, 0 and radius is r. So this is kind of one of those key things to know. And we're going to come back to improving that equation in a minute. So we'll practice a few more. So in addition to knowing how to write an equation, right, parts C and D focus on 2 other things, sketching and describing. So if I give you an equation, can you draw a picture of that circle? It's a sketch, so it doesn't have to be super accurate, but it should be semi-accurate. All right, so you'll notice in this equation, let me zoom into this, we don't have a squared here. All right, so you'll notice this is 36. So that doesn't mean our radius is 36. So if you notice, if we rewrite this, I can rewrite this 36 as 6 squared, which means technically our radius is equal to 6, since it follows that same format of Pythagorean theorem. All right, so here's a lot of times people struggle with graphing this. Here's how to make this easy for us. So let me just remind us our radius is 6. So I'm going to start with, we always know the circle's at the origin according to all our previous examples. So we know where the center is. Radius tells us how far we are from the center. So I'm going to put, I know for sure my circle is going to go to 6 in all directions. All right, so 6 to the left and to the right, 6 up and down. And let's see if we can sketch a circle that goes through these points. All right, something like that. And there's your circle. All right, you do your best to draw that. At the very least, to make sure you plot those 4 points. And then sometimes you might have something that looks jaggedy. It might take you some time. But hopefully you'll at least have those 4 points accurate. All right. And then describing a graph. If I give you the equation, what can you tell me about it? In this case, you'll notice it's the same format. This part tells us where it's centered. And so in this case, all our previous examples, you'll notice, have been at 0, 0. And this number on the other side has always told us something about our radius. In this case, 0 is the same thing as 0 squared, which means our radius is of 0. Well, if I try to actually graph that, really that's just going to look like 1 point. So there is no radius. There's no large radius or small radius. It's so small that really it's just a point. All right, so that's kind of a quick run through of different types of test questions you might see. All right, so that's nice and all, but not all circles are going to be centered at the origin. All right, so this is probably where it gets a little bit more interesting, and it might be more familiar to you if you remember our quadratic functions. All right, and so that'll make sense in a minute. So here we have a circle with center at 3, 1 and radius of 5 units. All right, so you'll notice the center's moved. It was at the origin and it got moved. If I actually draw a line, you can see this went up 1 and over 3. All right, so we got moved to 3, 1. And if you move the center, the rest of the circle moves with it. All right, so that also means all this right triangle that used to be in the center is now moved, but it's still there. So we still have this picture of a right triangle. Right, what we want to know is what's the length of PB, from P to B. That's not given to us, but we do know this hypotenuse is a 5. And we do have some idea about these measurements. I know this has a height of y. And I also know from here to here is a measurement of 1. So if I look at this, from here to here is y, but I don't want this part. So I'm going to subtract that piece. So you'll notice there's this piece missing here. So y, let's take away that piece. So this is really y minus 1. So let me write this. This is y minus 1. And if I look at AB normally was here, and it went somewhere over here, however long B was. And usually we would just say that's x. But now this is all x. And so this whole measurement is x. But we don't want this piece. And this piece is 3. So this is going to be x minus those 3 units. I don't want this. All right. So let's write this as x minus 3. So this is, let me write that on the picture, x minus 3 and y minus 1. All right, so now we know the sides of that triangle, which means we could use what we know about Pythagorean theorem again and write an equation for this circle. Alright, so from what I remember, it was always something squared plus something squared equals to the radius squared, alright, which was 5. Alright, so we have our sides that we're going to plug in. So we had x minus 3 and we have y minus 1. Alright, that's it. We don't need to solve this. We're told to write an equation, and that would be an example of an equation you could have. Sometimes we might multiply this 5 out to be 25, but it looks good like that. It reminds us of what the radius is. Alright, so part D to this gives us a few more to try out. If you want to try these on your own for a second, this would probably be a good time to pause the video and see if you can do this on your own. So I'll give you a second to do that. 1 second. All right, so let's continue. Hopefully you tried it. If not, that's all right. Let's walk through this. So we're looking at writing equations for all 4 of these. They give us information a little bit different in each one. A circle with center at 2, 7 and radius of 1 unit. All right, so I'm going to start with the structure I'm familiar with, which is kind of what I did on the previous problem. I always like to start with this Pythagorean theorem and then plug in what I know. So I definitely know the radius is 1 unit, so I'm going to plug that in. And I know there's always supposed to be an x and a y. And you'll notice on the center, it tells us exactly what our x and y values, how our x and y values are being shifted. So this is going to be x minus 2 and y minus 7. All right, so keep in mind, don't forget, on that previous example, point up, we had a minus 3 and a minus 1, right? Even though our center was at 3, 1. So notice there's always that minus in there. So it's the same thing on this problem. So let's see, let's look at the graph. So let's say the information is not given to us in words, but it's given to us in a picture. So here we have a circle. So usually what I like to do is just focus on labeling what I know. So where's the center of the circle? So this is at 3, and this is a 3 also, huh? All right, so center is at 3, 3. And what's the radius? So how far is it from the center to the edge? So if I look down, this looks like it's at a 5. So keep in mind, this goes all the way to here, that's 5 minus this 3, I don't want this, so this is going to be 1, 2, 1, 2. This is going to be a radius of 2. All right, radius of 2. All right, and that should really be all the information we need. So this is going to be x minus 3 squared plus y minus 3 squared equals 2 squared. All right. And then let's do 3, circle for which 5, 0 and negative 5, 0 are endpoints of a diameter. All right. So this time they didn't give us the center, but they gave us, it might not be very clear, but they gave us the endpoints. So wherever that circle is, I know that the endpoints, the diameter, oops, let me redraw this. The diameter, this is going to be 5, 0, and this other point is going to be negative 5, 0. And so the nice part about the diameter is it kind of gives us an idea where the center is. So if this is 5, this is 5, and this is -5, this must be at 0, 0. All right, so you might have to sketch that one to help you out. But really that information was telling us two things. Not only does it go through the origin, but it also tells us the radius is 5. Right? So I'm going to write that information down. So center is at 0, 0, and radius is equal to 5, which means, like the first examples we did, x squared plus y squared equals to 5 squared. Right? And there you go. Again, we're not solving these, we're just writing the equations out. And here we have another one. You'll notice it's shifted to the left this time. And all the other ones were kind of in this area. So same thing. I like to focus on what's the center. So this is going to be at -2. What is this, 1? So center is at -2, 1. And we need to know what's the radius. So it looks like 1, 2, 3. All right, so that means our radius has, let me write it here, radius is equal to 3. And we're going to do x minus a -2 squared plus y minus 1 squared equals to 3 squared. All right, which that looks a little odd. So let's simplify this. This is going to be x plus 2 squared plus y minus 1 squared equals to 3 squared. All right, there's our equation. All right, I know I'm going through this kind of fast, but I'm hoping with the summary that I have coming up, this might make more sense. All right, so in this summary, really what it comes down to is there's this general formula for our equation of a circle, that I have here at the top. I mentioned this earlier, kind of similar to our quadratic formula. You'll notice the x minus h squared that we've seen before when we graphed our parabolas. You'll notice the h and the k value like before. And then this still follows the same format of Pythagorean theorem, except now this, in this case, our center, instead of like our vertex in our parabolas, it still represents our locator point. H tells us whether it's shifting left or right, and our k value still tells us whether it's going up or down. And then R will tell us how big it is. Kind of a little bit like our stretch factor in our parabolas. So still kind of have some of the main components. So center of the circle is going to be your HK, which is also could be kind of our locator point. Where is the circle located? And then our radius of the circle is how big, right? So the size of this. How big is it? The size. All right, so this is kind of the key part that you need to know, so that if you get problems, this is the last problem. Ideally, this is the type of problem we want to be able to do, where we could solve systems of equations that involve not only circles, but maybe linear functions as well. So if we try to graph these, hopefully you know how to graph a linear equation, right? Because that's in our form of y equals mx plus b format. And our circle, I know that's a circle because it's in our circle format. So y, and then that would be probably like a 3 squared. All right, so let me try to see if I could do this really quick. Um, this is, I'm going to label my circle. So this tells me that my center is at -2, -3, right? Because it's a plus, so that means it's the opposite, right? Just kind of like we looked here. And then our radius, this is really going to be the same thing as 3 squared, which means our radius is equal to 3. All right, so if I start to sketch this out, I would start at -2, -3, which is somewhere around here. -2, -3. And then, again, plotting points. 3 in radius is 3, so we're going to go 3 in every direction. 3, 3, 3, 3. And see if we could sketch a circle that goes through these points, something like that. And then we still have our linear equation, which means our slope is at 1, and our y-intercept is at 0, 2. All right, so 0, 2 is right here, and the slope is 1, which means we should have points that go through all these. Rise over run. So if I sketch a line that goes through those points, hopefully something like that. All right. So the nice part here is you'll notice they intersect in 2 places, which represent our solutions. It says solve for the intersection points using algebra. Well, we've done it graphically, and so we could actually use our algebra to prove those points are correct. So -2, 0, and what point is this? -2, -3, -4, -5. This is -5, -3. All right. So you could plug that in, plug this y value into here, and solve it algebraically, and you should be able to get both of those coordinates correct. I'll let you try to finish that one on your own. If you have questions about that, go ahead and let me know. Again, at the end of this lesson, there's always a review preview. In this case, it's problems 6 to 13. There is math notes available in this lesson to help you with problem 10-6 on volume, I believe. Everything else is a good review of prior topics, so I strongly recommend trying to do this as well. Alrighty, hopefully this was helpful. Thanks.